And with that, I'd like to hand the webcast over to Justin.
Thanks, Carol. So today what we're doing is we're doing container security, and I'm going to try to hit this from multiple angles because this specific webcast is designed for what we call the all-around defender, the folks that are responsible for a little bit of everything. So I'm going to hit containers from hardening best practices, logging, forensics, incident handling, you name it. We're going to try to broadly cover everything, but still dive down into the technology. So my name is Justin Henderson. I am the author of SEC555 SIEM with Tactical Analytics. I'm also the co-author of SEC530, Defensible Security and Engineering, which is kind of more along the lines of what this specific webcast is geared towards, as well as SEC455 SIEM Design and Implementation. I've got a bunch of certifications at 61. I've been in the field, I think somewhere around 15 plus years. And I do a lot of GitHub projects where I try to release stuff for free. So that's me. Hopefully that'll meet the needs of necessity. And at the end of this talk, I will be uploading my PowerPoint slides to this GitHub site. But again, remember at the end of SANS webcast, they throw them in the archive, so you have access to the video and everything after the presentation. So here we go. I'm basically breaking this down into 3 sections. We're first going to start off with hardening and best practices. So whether you're deploying containers tomorrow or you've already have them in production, what are things to consider from a security best practice? What are ways that attackers will abuse containers, try to do privilege escalation and escape? How can we segment them? Like, what are the things we need to be considering as we deploy containers? And by the way, when I say containers, I don't really care whether we're talking Containerd, Docker, Kubernetes. For the most part, I'll probably be giving examples of Docker, but these principles that we're going to be talking about will apply to cloud instances, on-premise instances, Kubernetes, and all of the above. So just know we're talking containers. From there, once we've talked about ways we need to lock down and secure the container services, we're going to flip to monitoring. This is the area where I really love, because there's this misconception that because things are ephemeral, they go away, that logging is infinitely harder than it would have been as a virtual machine or a dedicated operating system. And I'm going to tell you right now, monitoring, figuring out what's happening, identifying attacks against your microservices, we actually have a ton of capabilities, almost to the point where I would even go so far as to say it can be easier. So before you believe me on that, just wait until I get to that section, because we'll go into the different ways we can do different levels of monitoring on our containers. And then we'll end with a few slides on forensics and incident handling. Again, containers are ephemeral, which means they go away. They're not permanent. Well, given that, if you know something's compromised, how do you run forensics? Like, how do you do memory acquisition and data acquisition? And, well, can you offline it? Can you how does all that work? So we'll end with a few slides on how to do incident handling and forensics with containers. So let's start with the hardening and best practices. First things first, we need to make sure we understand the architecture. We'll just briefly go through this. If I was installing, say, Docker or Kubernetes on my own machine, well, then I would probably have something like a Ubuntu, a CentOS, a Red Hat, pick your host operating system. I would probably deploy it as a virtual machine if you're doing this for a home lab. And then you would install your orchestrator, whether that's something like Docker, Docker Swarm, Kubernetes, and from there you start deploying containers. Now, these bottom 2 layers, the Docker service and host operating system, if you're doing something like Amazon EKS or Google Kubernetes or wherever you're putting your containers, well, those roll up into a container as a service. So you can replace the bottom 2 layers with a commercial container service. From there, both are similar in that we're deploying containers, such as Apache. And the Apache is basically a process spun off from your container service, and it runs, Apache with any forked workers it has. It has its own set of logs. It has its own IP address. Technically, it has its own name, similar to a virtual machine, but it is not a virtual machine. It is a process that is isolated and deployed using container services. Now, this is why things are a little bit challenging, because as a virtual machine, we'd still have to worry about patching the host operating system. We'd have additional overhead. We had a lot more software installed on the guest operating system. Logging was the same way we would always do it, where in this case, it's not. Also, with containers, I could deploy Apache, remove it, and upgrade it to a newer version within seconds. Well, your logs are now gone. So there's a couple things that we're gonna have to deal with here, but we need to understand what this architecture kind of looks like. So I guess first things first, we're just gonna kind of dive into some hardening and best practices. Here it is. If you read through guides, for example, NIST has an article on securing containers. And one of the recommendations from them, as well as multiple blogs, is when you deploy containers, if you're deploying your own host operating system, then you should pick a host operating system that is dedicated to running containers rather than a general purpose. So for example, I might come into your organization and deploy containers, and I traditionally would install something like Red Hat, CentOS, or Ubuntu, and then I would install the container services on top of them. Well, the problem with this is I've got a bunch of extra software on those boxes that you don't necessarily need to run containers. So instead of doing this, what we can do is deploy a container host operating system. This would be things like Fedora CoreOS, Rancher OS, VMware Photon, and what these are operating systems dedicated to running containers, so they don't have extra services and features that you're not going to use. Like if I run Ubuntu as a desktop, for example, I have all sorts of additional binaries. I have extra services because it's a multi-purpose network operating system. If I run a container operating system, well, the footprint is much smaller because it literally has the binaries and services necessary to scale and run containers. So the concept is, if one of these is going to be attacked, it is much less likely to be attacked over a container operating system. Now, to me, this is a double-edged recommendation. If you're a small shop, you only have a few IT folks that are going to be maintaining containers, I honestly would probably push you towards a general purpose operating system rather than a container operating system. And the reason I'm saying this is if you have to learn how to deploy and maintain a brand new operating system and all of its little niche settings, you're potentially going to be less secure because you're not deploying it as tuned and securely. So smaller shops, I probably would still say, hey, I understand the container OS is a best practice, but for smaller shops, I probably would still stick to your general purpose. For medium to large, where you have the staff to dedicate to deploy the containers, maybe lean more towards the container operating systems. Again, because they're purpose built. And from an architecture standpoint, one thing we need to be considerate of is when you deploy containers, different containers meet different purposes. For example, you might have a bunch of web services that deal with credit card transactions. Well, that means you're under PCI compliance, and there's a higher risk because you might get someone trying to steal the credit cards. But on the same token, you might have other web services that are just basic static websites that are providing information about your business. Well, if both of these are internet facing, well, they have different sensitivities.
Hey, Justin.
Yeah.
Justin, sorry to interrupt. The slides aren't moving.
No. How about now?
Yes, I see physical separation.
All right, slides are a good thing. Okay, I'll keep going. What happens if one of these containers gets compromised and used to attack another container? So the concept here is just like with hypervisors, you don't necessarily want a high-risk internet-facing application on the same host as your domain controllers, for example. So what you can do instead is try to separate these. This is a tough pill to swallow, but you don't want to mix and match different sensitivity levels and compliance requirements. So, okay. A different thing too is we usually use vulnerability scanners to identify what assets we have and to lock them down. But when you're deploying Kubernetes, Docker Swarm, they don't usually get as deep as they should. Like, okay, you're on Docker 1.1, time to upgrade to 1.13. Okay, that's great, but that's more dealing with patching. What about the settings within the orchestration software? Like, do I have change auditing? Do I have health checking enabled? Do I have namespaces deployed? Like, there's a bunch of settings you can do because the defaults, quite frankly, are, well, they're horrible. they're not that great. So you can deploy tools. For example, Docker Bench Security is an open source GitHub project. You pull it down and you just run it as a script. It is updated. You just pull it and it'll go through and it'll say, okay, I see you're running Docker. This is how you're configured. Here are the things you need to fix. So in SEC530, we do this as one of the labs because they see and they actually start to mitigate and fix some of these. Most of these are easy changes. A few of them, you really got to understand what the setting is, because if you change it after you're in production, bad things will happen. One of these is user namespaces, and I'll talk about that here in an upcoming slide, but this is auditing tools for your containers. Some of your cloud access security brokers, CASB products, can do this, or there are commercial products dedicated to being kind of a vulnerability scanning and auditing tool for containers. When we're using a container service, we kind of have the argument of which is more secure, a container or a virtual machine. And to be honest, I really don't like that argument because it seems kind of, it seems pointless because they are very, very different. If we're comparing virtual machine escape to container escape, well, then I would say you're far more likely to have someone escape out of a container than a virtual machine. But that doesn't mean that virtual machines are more secure than containers. It just means in that one aspect, containers lose the battle. You know, they haven't lost the war, they just lost that battle. And because the concept here is, when I deploy a container, so the top box, the Ubuntu host, I'm showing where I'm listing my Linux kernel. And then I deploy a CentOS container running bash, and I again list my kernel. And you'll notice in here, they both say the exact same thing, even the 132-Ubuntu. But the CentOS container is running CentOS. It's yum and RPM based, where the Ubuntu host is apt-get Debian based. But they run the same kernel. And that's because container technology is basically using process, network, and all sorts of isolation capabilities built in to your Linux kernels. So therefore, if I can abuse the kernel, usually from like lack of patching or lack of security settings like AppArmor, some GR security, any capabilities you're adding that are kernel level protection mechanisms, well, then you could potentially escape from a container into the host. There are some things we can do to tune this and make it harder to do, substantially harder, but it is still a possibility. So in here, you'll notice the PSAUX on the right. On the right, I can see, hey, here we're running CentOS with bin bash on process ID 5338. But in the container, bin bash shows us process ID 1. And the concept here is this is piggybacking off of Linux namespaces. A Linux namespace is well, there's kind of multiple layers of this. It's things like process isolation, network isolation, file system CH roots. Like there's multiple isolation technologies going on in here. By default, Docker or container services are running as root, and while they do kind of use a process namespace to isolate and hide, PID 1 versus the 5548, or whatever the process ID was on the previous line. The concept, though, is still problematic because that default namespace still lets me run a container as root and access all sorts of things as the host root account that I really shouldn't have access to. For example, if I'm in an environment, I do a lot of contract work, and if I'm in a client's environment and they're running Docker, and they say we've locked this down, but they've still got it configured to use the default namespace, I can log in as a standard Linux user, run docker run -it -u root. -u root says run this container as root. Volume map the host to a kind of like a symbolic link of /hostfs. And now I have a root account inside of the container, but I can arbitrarily modify files of the host operating system if I go into the host fs folder. That means I could add myself to the sudo group, the wheel group. I could create new accounts by modifying etc password and etc shadow. I could delete files. I could do all sorts of bad things. But if I want to make that less possible, I can turn on what's called user namespaces, or what's kind of more of an experimental feature called rootless mode. I don't know if I'd recommend rootless mode yet because it is experimental, but user namespaces are one way to change how your operating system is mapping UIDs and group IDs. In this case, I could run Docker using the use RNS remap and just set it to something like default, and that will use a special Docker account to isolate even farther different namespaces and IDs so that even if I run the container as root, well, you're not actually remapped under the context of the real root on the host. So now I could still technically map the host file system, but if the user I'm remapping the namespace under did not have access to certain files on the host, I still can't modify them. So that is a good recommendation to follow. The only caution here is if you're already in production and you enable that, you have to re-download all your Docker or Kubernetes images and re-spin them off, because the remapping is going to change the folder structure under like var lib docker. So that's something you want to put in place ideally before you go in production, or you need to come up with a game plan to roll into it. So you do have to be very careful with that one, but that is a good idea to help with privilege escalation. And speaking of images, when we pull images, we are reaching out to some type of registry service. Most often is like Docker Hub or Amazon's registries, or whatever, Google's registry, wherever you're getting your images from. And an image is basically the software captured and ready to spin off and deploy containers. So you download or set up your own images, build your own images, and then you deploy from those images. A big security concern in the container space is that you download a malicious image. Now, if I go out to Docker Hub and I find Apaches or Nginx or MySQL or Microsoft MySQL, well, if they're officially from the vendor, the chances that they're compromised are fairly low. It's still possible. Someone could have broke into like their equivalent of a Jenkins and snuck in code changes into that build pipeline, but it's less likely. If it's an image from someone you don't know, let's say like my company, HA Security Solutions, we have a lot of Docker images on Docker Hub, and you pull them down, the problem is you don't necessarily know what's in them. So one way to combat this is to implement trust. Kind of the old school, well, if it's digitally signed from someone we trust, then it's good. It doesn't always work, by the way, but it's called the Docker Content Trust System. When you have this enabled, it's basically saying I'm only going to deploy an image that has been digitally signed by someone I trust. Now, by default, something from Docker Hub built by Docker is trusted. Outside of that, you have to start adding keys. So for example, if you've ever used solutions like Security Onion, they use a lot of containers, and if you look under the hood, they're only deploying ones digitally signed from Security Onion. So you can go in the config file and say, these are the image repositories we trust. Outside that, when you try to deploy them, don't allow it. The only problem I have with this is just because it's digitally signed doesn't mean it's secure. So I could have an image that I as a company have built, but maybe someone broke into my systems and they injected malware into the image. I digitally sign and upload that to a registry like Docker Hub, Now you're pulling down something that's digitally signed, you don't technically know what's inside the image. By the way, one way to handle that is pull down the image and literally crack open the files and analyze it. You could deploy an image, run it as a container, or even offline go into the image itself and start doing things like antivirus scans, threat intelligence lookups, or you could just run it in a sandbox and see and monitor its activity. So you don't have to just implicitly trust, you can analyze. I personally, rather than digitally signing my containers, my images, is I do automated builds, which means Docker is the one building my images, but you can see the Docker file it was built off of. So you don't have to trust me. You can literally see what it did during image build. Now, you also can just deploy your own registry. So by default, if I do docker pull nginx, that's going to pull using Docker IO and pull out hub.docker.com or wherever this is stored at. Now I have the nginx image. I could instead create my own registry. I can have this be authenticated, TLS encrypted, and I can add different layers of security and only have the repos that I've pre-analyzed ready for production. Now, this will work again whether you're on-premise or in the cloud. Basically, you just pull into a registry box, you install it as a registry service, you install a TLS certificate, pull in the repos, mark them and tag them with whatever version numbers you want, and then you point your other container services at that registry. So in an environment where you're trying to have high security, you might block access to the registry, the public registries, from all assets except for your private registry server. Then you lock that one down, and only via process, someone manually jumps on the box, pulls in new images, analyzes them, and then makes them available internally. Then your internal assets, you point at your private registry, and they can only pull images you've authorized for them to pull down or push. So that's something that is widely beneficial, because otherwise you can pull down any image, which could have hacking tools, could have default to root, and maybe you don't allow containers to run as root, or various settings. Now, when we deploy containers, this is kind of interesting versus a virtual machine in different aspect. We're comparing containers to virtual machines for a second. If I deploy a virtual machine, I would say, okay, you get 4 CPUs, maybe 8 to 16 gig of RAM. And if that box gets compromised and a denial of service attack runs, well, at max, it's going to take 4 CPUs and 16 gig of RAM. But let's say that VM was on a 1 terabyte of RAM, 120 core CPU box. Well, who cares? It's only going to use the virtual memory and CPU that I allocated it. But on the container side of the fence, by default, a single container can access all 120 cores and 1 terabyte of RAM, as well as disk and IO. Well, that's problematic because that literally means that if I compromise one container on a physical server, I could denial of service the entire box, all containers on it in totality. Now, the way you limit this is you'll use a capability called control groups. Control groups let you set limits on a per container basis. So I could say this is an nginx box. I'm only going to let it use a max of X gig of memory. I'll give it a max of this many CPUs. It can only use this much storage disk, and you start to lock down even things like file descriptors. Then if the box gets compromised, that container, well, it's not going to denial service the entire system. This could also just be if you have a container that the software's got a bug and it just starts acting weird. Maybe it has like a memory leak and it uses more and more over time. Well, now it'll hit that hard upper limit rather than taking the whole 1 terabyte of RAM down with the ship. So we use control groups to fix that. As we deploy containers, especially when we're using orchestration like Kubernetes or Swarm, we start to run into an issue where we're sharing things like passwords, private keys, or just anything that you would consider a sensitive piece of information that the service needs to know in order to deploy. But let's say I have 10 physical boxes I'm deploying containers to all of them, I really don't want to be effectively copying and pasting those passwords and certificates in the clear. So what you can do instead is do a feature called secrets. Now, secrets, I'm just going to be honest, are not a perfect solution for this. It does just make it a better, makes it less painful. Concept here is you load secrets. In secrets, you put private keys, you put your passwords, you put whatever it is, and now your management orchestration service, when it deploys a secret to a container, that is encrypted in transit to the container and then technically at rest. The problem is you still technically can reverse out a secret because, well, it has to be accessible somewhere. But I have to usually do things like privilege escalation or gain access to a specific container. Then I can go in and grab that secret file. But it is a lot harder to do than if I just send it to it, mount it as a file, and so on. So secrets is the way we can securely transmit these. Other things we should do to worry about container escape, again, more likely than virtual machine escape, is quit letting our images or containers deploy as root, or really as an admin account. So I download, say, I use Elasticstack a lot. If I'm deploying Elasticsearch, the image deploys as root. Well, what I could do is make sure when I deploy that, I set -u, a user, and I could try to deploy it as a user I call Elasticsearch. I might have to go through and make sure permissions are correct to the different folders or volumes I'm accessing. But if I take the time to do that, now if that container gets compromised, well, first they'd have to privilege escalate from that Elasticsearch user to a root account. Then from the root account, they can try to jump out of the namespace. But it becomes a multi-step, increasing difficult process. So to do this, when you build your images, you might have to create that new account first. So that would be something like the run user add command and then setting the user to be that service account. This is where you might have a Docker file that deploys from an official image, but then the only thing it's doing is adding another account and then downgrading to that account so it doesn't run as root. Just because the vendor does it that way does not mean that it has to be that way. Be careful. The other thing is when you run things like, say, /bin/password_d, the utility for changing your password on Linux, that has the set UID bits permission. What that means is when you run that binary, you actually run it as the owner, which in this case is root. Now, if password_d had a vulnerability, you could use it to arbitrarily run like a bash shell, but as root, and now you're root. So it's a quick win privilege escalation. Now, password_d ideally is securely coded and that shouldn't work, but in a container, you might want to run something like this run command, the for loop, that finds the set UID or set group ID and removes the permission. But wait, Justin, I can't run password_d then. Well, are you changing your password in a container? Really? I mean, there's a lot of things that have set UID that we just don't need it in a container system. So well, in that case, we'll find them and remove them. Now, let's switch gears a little bit here. We've talked about some best practices and hardening and things to do to minimize that container escape. How about monitoring? Like, okay, we're deploying a massive web farm of thousands of web services and databases, and well, I still can have SQL injection and cross-site scripting and all the normal attacks, but now I also can have attacks against my orchestration platform, Docker Swarm, Kubernetes. So what am I looking for? How do I get those logs? And is this going to take massive amounts of staff and be super difficult? And of course, you still need to monitor the host operating system or platform that you're hosting these on. I'm not going to cover that in this talk. If you have Windows and Linux, well, then get your logs from Windows and Linux. I've got lots of webcasts in the archive or in the GitHub repo that you can reference for that. We're going to focus on container service logs like Kubernetes and Swarm or Docker containerd versus whatever application you're deploying as a microservice. Let's start with the actual orchestration platform. So Docker Swarm, Kubernetes, you're deploying containers. They log, hey, you've just created a network, you've deployed a container, that container is attached to a network, and like all these different things are occurring. The problem is, well, what the heck are you looking for? Like, which of these is bad? So here's where you really have to map out what are you deploying and why. If I'm deploying Nginx and MySQL and some type of load balancer, maybe even Nginx reverse proxies, like if I'm deploying these and all of a sudden someone deploys a CentOS box and runs bash, should that have happened? Like, well, because technically someone on your staff or a compromised box that has access to deploy a container could deploy a container for the instances of mapping and accessing files in other containers. It's called a sidecar. If that's authorized, that's good. If it's not, well, that's epically bad. So I can monitor for creation of containers or pulling of images that they're not authorized to occur or it happened outside of change management. I could also look for obscure logs that I've not seen before, because that could be indicative of someone trying to launch exploits against your orchestration software. Now, when these log though, I want to be able to bring these into your logging platform, your SIEM, whatever it is. I don't want to just be running things like, Docker commands to output the logs. So if I'm on premise, well, these are probably just files and I can just grab them just like I would any other file, ship it off and syslog, ng, rsyslog, filebeat, whatever you're using. If it's cloud, it's a little bit different. For example, Amazon EKS, the Kubernetes service, for that, it still has these kind of logs. You just need to turn them on and tell them where to go. So they make it pretty simple. I love this. You just run a command. Now it logs your daemon logs to CloudWatch. From there, you just need to find something that allows you to pull logs out of CloudWatch. I personally like using Logstash because then I can pull with a free tool and send it to anything. Elasticsearch, McAfee, Nitro, Logarithm, QRadar, some type of generic logging service, syslog. So there are lots of free ways of pulling out of this, and it's simple to enable. Again, the difficult part is not getting the logs enabled and pulling them, it's figuring out the use cases you're monitoring the logs for. But then we come to the containers. This is still the meats and potatoes of the conversation. I still need to monitor my web servers for web attacks. I still need to monitor my databases for unauthorized access and database attacks. Now, the problem isn't how to do this, it's which option are you going to pick. We can, when we deploy containers, have persistent data volumes or bind mounts. A bind mount is similar to like a symbolic link, but it's from container to the host that it was deployed on. A data volume, well, that could spread between hosts. These are usually the options that when we deploy containers, the containers are ephemeral and get purged, but the data volumes or bind mounts do not. So I could have a Nginx box mounted as a data volume or bind mount and just access the logs normally. I'll show this on the next slide. You could recode your application that you're deploying in the container to syslog or S3 or do remote logging instead of locally logging. That's kind of a nightmare because you're custom coding. You got to know what you're doing, and hopefully you're using libraries that do it for you. Or we can do concepts like sidecars or daemon log drivers. I'll cover these as we hit the slides. So option one, you deploy Nginx. Well, Nginx logs to varlog Nginx. You have an access log, an error log. Well, if I'm doing a bind mount, then varlog Nginx in the container actually is writing to, in this case, a path I chose, logs custom app1 Nginx. Well, that means on the host operating system, I could deploy an agent or tell syslog, hey, read from the logs custom app1 Nginx folder and ship the logs off from there. Well, if it's a persistent data volume, well, I have a data volume path on the host. Some agents are smart enough to do that. Or I would have a container I deploy that is a log agent that also has the same data volume mapped. And in which case, it's reading the logs just like traditional approach. Read the logs, ship them off. Pick your agent of choice. Choose your poison. This tends to be a fairly simplistic approach because it's kind of how we've always done it. The only concept is, are you picking up with an agent on the host or from a container that can then mount the same data as the Nginx box? That concept is considered a sidecar. So it's still very similar, but maybe it's a container as a service approach, it's a platform, and you don't have direct access to the host operating system. Well, in this case, when Nginx is deployed, you also deploy what I call the logging container, the sidecar. In this case, the logging container has the same volume or bind mount to the same data. So, okay, if it's running a log agent inside the logging container, it sees var log Nginx, it's just kind of a read-only copy. In fact, when you do the volume or bind mount, you should mark it as read-only because you don't need to delete it, well, unless you're doing log rotation, in which case you would, but you can give it access to it, and this could be one logging container per every other container, or you could have one logging container that technically mounts multiple paths to other containers. You actually get a pick here. Now, my personal favorite option is making sure you have a log driver configured. This is a little kind of it's a little different versus a traditional approach, but in our containers, what we do is we tell the daemon you're deploying, Kubernetes or Docker or Containerd, hey, I want you to grab standard out or even standard error, and I want you to log it, and I can tell the logging driver, hey, syslog this off to my SIEM. That's an option. So I'm literally logging, I just set the driver to syslog and I fork it off. I personally like the JSON file. In this case, it grabs all the standard in, the standard out, and the standard error, and it outputs it to a JSON file that Docker or whatever service you're doing monitors. I can set a max file size so it doesn't chew through the hard drive space. And then from there, I just need to find something that will go read that JSON log and then ship it off however I want. So for example, if I enable JSON file logging, I can then deploy a log agent that understands it. So in my environment, we do like, we host our own cloud version of the Elastic Stack, but we deploy those as containers. The problem is I want to be able to see the logs that Elasticsearch, Logstash, Kibana, all the different things we're using create, because if there's errors, I need to proactively fix them. Well, I guess in that case it's reactively, but I want to monitor for things I'm not used to seeing or errors because they could go from small issues to big issues. So we enable the JSON log driver and then we deploy FileBeat. And in FileBeat, there's an input for Docker. In this case, it will dynamically find all the containers on the host and then start to grab their, in this case, those JSON logs, standard in or standard out, standard error, and it just picks it up and ships it off. And in this case, we ingest it back to our cluster, or it's really a separate cluster anyway. And it does this because it goes into the varlib Docker, because all your containers technically mount and the file systems and everything they're doing is found under that. And the cool part is, let's say you're deploying stuff in Amazon EKS. Maybe you're even doing the Elastic Stack on Amazon. Well, technically, if you're on EKS, you can do agents like FileBeat, point it to EKS, and it will do the same exact thing, even though you're not actually gaining access to the full hosts. And the reason this works is because technically there's guest virtual machines deployed in Amazon EKS that then have the orchestration software on top of them, but it's under your Amazon instances and regions. So I can point to them with these agents and it will crawl through and figure, oh, you deployed 50 new containers. Here, let me grab those logs for you. And I can, inside of this, also say, hey, when you're grabbing the logs, like the standard out, standard error, can you also analyze the container to see if it has an Nginx folder, a MySQL folder, and now it's application aware, and it'll dig farther down the hard drive to grab those logs for you. This is my favorite way to get the logs from container services because it's autopilot. You basically clap your hands and say go, and it crawls through and it grabs them for you. Now, incident handling and forensics on containers, though, is, well, this gets different. Logging, I felt like we have a lot of options, and to be honest, I think it's easier than, if I'm going to monitor 1,000 different containers versus 1,000 VMs, I'd rather monitor 1,000 containers. It's quicker, it's more efficient. But incident handling and forensics, well, there were a lot of commercial and open source tools that handle VMs really well. That's because it's a host operating system effectively, whether it's virtual or not. With containers, well, there's starting to be some open source stuff. I don't personally know of ones I'd be like, yep, that's the best one, I recommend that. Commercial tools are doing a better job of it, but it is newer to the field, even though containers have been out a long time. Because the problem is you're not grabbing a host operating system hard drive and a host operating system memory, which then is sub-analyzed. Instead, we're grabbing really processes. Because remember, this is effectively processes being deployed, which are isolated from the operating system, but they still have IP addresses and have their own namespaces. So in here, we have containers that they're not intended to permanently run. They're deleted, they're ephemeral in nature, but we need to be able to do data acquisition and analysis in the event something bad happens. If you jump the gun and be like, oh, that box is compromised, and you stop it, well, depending on how you're deploying this, sometimes there isn't a stop button. Sometimes stop actually means delete. Please make sure you know the answer to that question. So you have to jump in there and figure out, okay, I'm running Docker. I did Docker run, therefore I can do Docker stop. Oh, I'm doing a service. I can't exactly stop a service because if I do, it actually deletes it. Okay, understand what happens, and then you need to kick off from this. The other trick is your containers, well, there's usually more than one, and they're spread out across unknown amounts of physical servers. So you have to be careful on how you're grabbing this data. Couple things here. If I'm trying to access the hard drive, I'm talking the hard drive initially, the files, there's a couple built-in commands usually into each platform. For one, this is, in like Docker, I can run a Docker diff, and what that's going to do is it's going to show you from a running container, here are all the file changes that have occurred since deployment. That means if malware overwrote a file, added a new file, deleted a file, it'll list them all out. So right there, that Docker diff command, that's actually epically awesome, because I'm seeing here's what's changed since the container deployed. You almost could deploy another container that's not infected, run the Docker diff again after a few minutes, because some files will change, and then use that as the whitelist to remove from the compromise box. So it's easier to get a data set of what should have changed and what shouldn't have changed, because containers are purpose built. That's kind of fun. So I have a web service and someone uploaded a web shell. They then launched the web shell, and that's how they were compromising access data. A Docker diff is going to show that pretty quickly. Another approach is I could run another container that is bind mounting to the volume or anything within the compromised container. Kind of the sidecar approach. I have a forensics image that I use as a sidecar to a running image, and then I'm analyzing data from that sidecar. That is fairly good at accessing files. To be honest, I don't know if that's a good option for grabbing memory, because it's going to be harder and maybe not as accurate to grab it from one container through another container. But for file access, that works really well, and I can grab the data just with all the tools you typically have done. Another option is, if you're in Docker or Kubernetes, is you could just take the running container that's compromised and say, turn this into an image. On Docker, it would be Docker commit. When I do that, it literally builds an image with a point-in-time snap of that container. That means you now can do offline analysis of that image because it's captured with that point-in-time reference. Now, the downside to this is when you're analyzing that new image, you're not getting memory. You're not getting what it looked like at the exact time. You're just getting the files at the exact time you did analysis. So when it comes to memory analysis, memory acquisition, we have to do things a little different here. And to be honest, this isn't bad. We have got a decent amount of options here. When you stop to think about it, containers are really processes that are then isolated from the host. That means if you can dump process memory, you have all memory for the container. So in 530, Security 530, when we're teaching class, one of the things we do in the lab is we actually have students go in and they use procdump, Microsoft sysinternals tool that works on Linux, by the way, because it's easy to just say, hey, go dump the memory from this process ID. So in the picture, it's 24840. And then now we can analyze the file that it creates, which is the bash time with the time stamp on the end. And we use it to show how easy it is to pull out things like passwords or things from memory because it's in that process. So if I have a Apache instance and there's 4 processes spun off inside the container, well then on your host, you need to dump 4 processes. Grab those IDs and dump them. There are multiple tools in Linux that will let you dump memory from single processes or multiple processes. So grab them and run them. Ideally run them from the host because the host can see all processes of all containers. If you're on a container platform, a cloud service that you can't do that for some reason, then you can do this. You can jump into the container that's running and then dump them from there. Now, that's a little trickier because you are doing live acquisition on a compromised box. You have to worry about things like rootkits, but you're basically doing a traditional memory dump via process memory dump that you would on a live system. So that's an option. The problem here is the tools you need to do that might not be in your images because they're containers. Lots of software is removed. So that gets challenged. You might have to do like yum install, apt install, or alpine install commands to get the memory dumping tools available to you. So, okay. One other thing I want to point out is NIST does have a publication, 800-190, called the Application Container Security Guide. It covers quite a few things, and it has really, like whoever put this together, the 3 names on the sheet, did a really good job of creating images and like diagrams to understand container technologies and namespaces and some of the concerns with orchestration. It doesn't cover everything necessarily we've talked about on our webcast, but it is a really good guide that I would recommend you read if you're tasked with securing container technologies. So with that, this talk was based on SEC530, Defensible Security Architecture and Engineering. We cover all sorts of concepts for all-around defenders, whether it's networking, switching, and routers to firewalls, sandboxing, PowerShell scripting, containers, public cloud, private cloud, zero trust. That's the course that this webcast is based on. We have a really cool coin. And if you're interested in SEC 530, it is being taught cybercast because of all the necessity to work from home. And the logging and monitoring, if you're interested in that, we cover those kind of concepts in 555 SIEM with Tactical Analytics. With that, I'm going to turn this over to Carol, and if anybody has questions, I will do my best to answer them.
All right, thanks, Justin, for that great presentation. I did see a question just pop in to the Q&A window. However, if anyone has a question for Justin, please put it into the questions window now. Our first one asks, have you seen a method to sidecar dump memory from a compromised container? I'm thinking in ECS, EKS, where you don't have access at the host level, but would still prefer to not install memory tools on the compromised container.
Yeah, that's a great question. It is quite a bit harder. It depends on the image you're deploying, but if you think about it on Linux, if I'm trying to dump memory, sometimes I can just go under the folder that contains the actual running memory and processes, and I can dump them, even though it's memory. So you can potentially, from a sidecar, mount that in the sidecar and then run commands against those folders and files to grab the memory. Now, I say that's based on the image because if the image is doing like memory hardening and security, the commands get harder and you'll have to get different tools. But if you think about it, everything in Linux is a file stream. So if you're mounting the right folders and you have root access to those, you should be able to read and dump that.
All right, thanks. Somebody said, yep, perfect, that tracks, thanks. The person who asked the question said that. Someone else says, no question, but just a thanks. And another question says, which can be the most dangerous use case which have to be detected by logging system?
So I'm assuming the question is, what's the most critical thing to monitor in containers? Personally, I think the answer to that is still the actual applications. The highest risk is someone's going to attack your web servers, your code logic. Maybe you have a shopping cart system, but there's a logic flaw in how the developer coded it. Well, to see attacks against that, you still need like HTTP logs, Apache logs, Nginx logs, database logs. So to me, the most critical thing you're still monitoring is your application logs itself. Now, for the orchestration platforms, those technically can be exploited. It's much less likely. What I'm more concerned about is someone getting like phished and then using those credentials to authenticate to the orchestrator and then deploy things. So for those, that's where you're bringing in like the Docker Swarm, the Kubernetes logs, and looking for unauthorized use. I'm less concerned about exploits as I am unauthorized use in that use case.
All right, thanks. Someone asks, can we have the slides? And is this session going to be recorded? And I'm putting that in the chat window. A copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. All right, next one for you, Justin. There are multiple POD or container isolation. From user experience, which one of the isolation methods is more suitable?
When you say POD, can they put in the chat window the acronym definition there?
Sure. While we wait for that, let's see. So this is from the same person. Maybe it helps. Isolation methods, overlay networks, Cisco, our plugin, Twistlock, or something similar.
Oh, okay, gotcha. Yeah. Commercial things like Twistlock are pretty awesome because now you have authentication to the orchestration and you've got extra isolations. I don't know if I've got a gut feel for which one I'd say I prefer best. I feel like if you go through hardening guides, like doing user namespace and other things, even without those tools, you have pretty solid security. The problem I'm seeing is most organizations don't dip their toes in technology. They dive right into the deep end, and then it's too late and hard to implement the lockdown and isolation capabilities. Commercial ones obviously make that a lot easier. So if you have the money, go for it.
All right, thanks. Someone says, really helpful, thank you. And someone else says, and thank you so much for all your efforts on this. All right, where can we find a list of commands, error codes, or other codes to look for when performing analysis on container logs?
I do not have a good answer for that one. I'm assuming you're talking from the orchestration software rather than the application. If you're talking about like the logs that you would grab, like the log drivers, that's absolutely specific to the containers, the application itself, like HTTP status codes and all that. If you're talking about the daemon, to be honest, that changes from versions and it changes from like Swarm versus Kubernetes versus just local Docker. I don't know of a good cheat sheet that walks through those. It's more of bringing the logs in and just running pre-analysis, grouping it, and then coming up with that. Because there's not that many of them. But if anybody else does have a list that they know of, feel free to pop it in the chat and I'll update the slide deck.
All right, someone says you rock. Signing of the images, it's not enough to be secure. Why?
So let's say I give you I build an image, and let's say I pull down CentOS, I install malware in the image, and then I digitally sign the image and you pull it down. The problem is you trusted my image because, hey, it's Justin and apparently I rock. But when you pull it down, you didn't realize that I had malicious code in it. All you know is it was digitally signed by me. So the fact that it's digitally signed just means, do you trust me as an entity, not exactly what's in the image itself. It's possible to have malicious code in the image, and without analyzing it offline, you're not going to know that. It is much better than just trusting everybody, but it's still possible you can have malicious code in it.
All right. Well, that's all the questions we have. Thank you so much, Justin, for your great presentation. Oh, I'm sorry. We do have more. They said signed how?
So in this case, you literally generate a key, just like you would for like a web service, and you use your private key to sign the image when you build it, and then you upload the digitally signed image. So in this case, anybody can pull a copy of your public key, and they're trusting your public key, but you're the only one that has the private key. So you're literally using private public certificate key pairs. Generate the keys, then sign. And if you do Docker registry digital signatures, you'll find a guide within the first 2 links that shows you how to do it.
All right, so he said, sorry, you mean signed in the main docker.io repo?
Yes, yes.
All right, let's see here. We've got some follow-up still on that. Wouldn't signed and on an internal repo amount to some level of non-repudiation? Repudiation? Am I saying that correctly?
Non-repudiation. Yes, it's going to say that someone internally deployed the image, built it, and signed it. So you should know it came from a trusted party. The problem with that still is, just like with any certificate technology, if somebody gets access to the keys, well, they can digitally sign whatever they want. The likelihood, well, depends on how securely you store your keys. If everybody has access, then you don't have non-repudiation. If it's in like a Jenkins server or something that it's the only thing, or admins are the only ones that have access to the keys, then I would say, yes, you have non-repudiation.
All right, thank you. If you are reusing private keys in containers, how does this impact compliance with FIPS 140?
So if you're using keys inside containers, that I don't know the specific requirement for that FIPS number you're throwing out, but I'm going to guess it's the same as it normally would be, assuming that you're transmitting them over TLS, which would be the secrets option. From that, you're still probably having to do the right algorithm strengths, but that has nothing to do with the method you're transmitting it to the container. That would just be making sure you have secrets enabled.
All right, thanks. Any guidance on correlation/coordination between build guides, container vendor tools, and monitoring?
Any guides for that? Is that what the question was?
Correct.
I would look at that NIST publication at the end of the slide deck. It actually goes through talking through some of that. That was this right here.
All right, thanks. Can on-demand students win a coin? This person starts the on-demand next week for SEC530.
Awesome. Yes. You don't win it for the day 6 challenge because you're competing against all on-demand students. But in the class, I'm really big on sharing is caring. If in 530 or 555 students write a blog, write a script, basically share information like this webcast to social media in any way, shape, or form. It's not a marketing avenue. It's literally just sharing how to do something cool. Then I dub them a creator coin, which is actually this coin, but it's blood red because you poured your blood into the community. I don't know. I feel like you shouldn't only win coins for competing. I think you should win coins because you're awesome. So for any of my classes, 555, 530, when you give back to the community and you email me and show me that, I send you a creator coin.
All right, thanks. This sounds more like a suggestion. Love to see a SANS webcast, perhaps DevOps on container security.
Sure. I think there actually is some in the pipeline. That's probably from Eric Johnson.
All right. So we're going back to the previous question. Someone says, Which means the scenario you described means you have a lot of bigger problems, right?
Which series of questions was this one from?
So I'm pretty sure it popped in. I'm not sure. Nick, can you can you
the one about
more information?
digital signatures?
Yes, I think it was container signing, he says. Thanks, Nick.
Yeah, it's if you don't secure the keys well, then you absolutely have bigger problems. If you have a process for digitally signing and making sure no one has access to that key, then yes. I think the argument he's making now, though, is if there's malware in a image digitally signed, you have bigger problems. And I would totally agree, because that means somebody somewhere got compromised and everything's going to hell. Yes, it's the whole key under the doormat, who has access to it conversation.
All right, thanks. Do you advise containers? I think they mean advise. Do you advise containers network communication with using routable IP addresses or just using non-routable IP addresses?
So I don't really care if we're talking in terms of like RFC 1918 versus internet facing. I personally am a huge fan of just using overlay networks that you can't get to from outside a container. And I don't really care where they are, because you're still effectively NATing through the orchestration software. I hope that answers your question.
All right, thanks. Do you have time to keep going? I know we're a couple minutes over. We've got 3 more questions.
Sure. Yep.
Okay. What would be the best place to start on container security?
I would say the setting that has the biggest impact is that user namespace. If you set that initially and then deploy, it's less likely to cause you mass heartburn. That tends to be harder for folks already in production. So I'd probably start with the namespace. But if you're not familiar with containers, then really it's just getting used to and deploying them. Remove root, pull down secure images, get the user namespace in place, and then after that's in place, start getting your logging. So it's just kind of piece by piece, focusing on a given task and implement it.
All right, thanks. This is a follow-up. Is there such a thing as a FIPS 140 validated crypto module for containers?
I'm going to assume the answer to that question is yes, but I don't know that for sure. Like Twistlock and other commercial solutions, when you say FIPS, I'm used to mostly the requirements to have high cryptography, in which case you can generate higher algorithm signed certificates in containers and for the orchestration platform. So I believe the answer is yes, but I don't want to incorrectly answer your question.
All right, how ISTIO security features are important for the whole security of the infrastructure? It's a must, in your opinion?
So can you copy that in the chat window for me? Let's see here.
Just did.
All right, let's see here. ISTIO security feature for the whole security of the internet. I am not familiar with the acronym ISTIO.
All right, let's see if they add to that. Should I play the Jeopardy theme song while we wait?
Open source service. I have not used ISTIO service meshing, so I do not feel like I'm able to answer that question for you.
All right, thanks. All right, well, that's all we have. Thanks so much, Justin, for your great presentation, which helps bring this content